In this video, I'm going to discuss the idea of universal gravitation. So again, this takes us back to Isaac Newton, and I put this picture up here because this is actually a picture of a tree that they claim in England is the tree that Isaac Newton was sitting under when the apple hit him in the head and he discovered gravity. Right? So the idea of universal gravitation is talking about the gravity between large-scale objects, or really any object that has mass within the universe. So when we think about this, we can think about the Earth-Moon system. So we know that the moon goes and it orbits around the Earth, and it's actually an elliptical, but for our purposes in this physics class, we're just going to deal with it assuming that it's circular. So it's basically circular motion with no strings attached. So what is that force that's holding the Earth and the moon together? And we all know that that force is gravity. So this is also the theme of the most recent hit movie with Sandra Bullock and George Clooney, Gravity. So she is actually orbiting the outside of the Earth once she gets detached from her spaceship. I haven't seen the movie yet, but I heard it's great. So basically Newton came up with this law of gravitation, this idea of gravitation, and gravitas means weighty or serious in Latin. And the equation for universal gravitation is, and this is a force, right? So this is the same Fg that we've been learning about already, but we can calculate the force due to gravity between two objects that have mass by using this equation. So you have G times m1 times m2 over r squared. This G right here is a subscript. It's supposed to be like the little g, like force due to gravity, just indicating what kind of force this is. The m's represent masses, so the mass of one object and the mass of the other, and r represents the distance between the two objects' center of mass. So we kind of got to think about that when we're dealing with two large-scale objects that maybe their radius makes some difference. However, if we're talking about like a person standing on the Earth, then the radius of the Earth would actually be the distance between the two center of masses, because the center of the mass of the Earth is right at the center, and our center of mass is so relatively small that it's negligible. Okay, so just something to keep in mind, that this R sometimes can be radius, but the actual definition of it is the distance between the center of masses of the two objects. Okay, so that leaves us with this G. This G is actually the gravitational constant, and Henry Cavendish is actually the person who figured it out. So he used this instrument in order to determine that the gravitational constant is 6.67 times 10 to the negative 11th. And anytime you have a constant, it has like some weird units here, and that's just so we can cancel the units out in order for the force to be, so that this doesn't really affect the overall unit. So if we see it's Newton meter squared over kilogram squared. So if we go up to the previous slide, you see up here you've got mass and mass, so that would be kilograms squared, and then this is distance, so it would be meters squared. So it essentially causes that unit to cancel out and for you to be left with newtons, or force. So let's go ahead and use this equation to figure out the mass of the Earth. So let me open up the Elmo. Okay, and we know the radius of the Earth because we have, they used back in like 300 BC, I think it was the first time we figured out the radius of the Earth. Somebody actually believed the Earth was round, and they just used light shadows and circular math in order to figure out, that the Earth had a radius that is equal to 6.38 times 10 to the 6th meters. Okay. Now we also have that gravitational constant, which is 6.67 times 10 to the negative 11th. Remember, it's newtons meters squared over kilograms squared. This constant is given to you on your tables of information, so you don't have to memorize it. It is on the piece of paper that you'll have in your hand at all times. The mass of the Earth and, large objects and stuff is not on your tables of information, but it will be typically provided for you in the question. It's not something that you have to memorize. Okay? So we have the equation that the force due to gravity is equal to big G times the mass, and let's just say we're on the Earth. So the mass of me on the Earth times the mass of the Earth all over r squared. And in this case, if I, just kind of look at, like, this is the Earth and I'm this teeny tiny little person on it, you can see that the distance between our centers of mass would be equivalent to the radius. My height and where my center of mass is so small that it's negligible. Okay? So in this case, the r would be the radius of the Earth. Now, remember this force due to gravity, that would be the force due to gravity on me. So that's, remember that Fg equals mg. So in this case, it would be the m me times g is equal to g mass of me, mass of the Earth, all over the radius of the Earth squared. So we can see here that mass actually cancels. So the mass of me cancels out, and so now all I need to do, I have all this information, I just need to solve for the mass of the Earth. So I know that gravity is 9.8 meters per second squared, and that's something that we actually, we can calculate just by dropping things over and over and measuring time. We can actually figure out gravity, okay? And 6.67 times 10 to the negative 11th is the constant. And then the mass of the Earth is what I'm trying to find, all over 6.38 times 10 to the 6th squared. So this is actually how we figured out the mass of the Earth. So let's go ahead and calculate this out. And I'm going to demonstrate how to do this on the calculator, because a lot of times the hardest part with this assignment is that kids can't use their calculator correctly. So let me show you how to do it. So when you're punching in numbers with scientific notation on your calculator, you should use this EE button right here. The EE button means times 10 to some value, okay? Because this number right here is a number. It is not a mathematical operation between two numbers. It is one number. So we want to tell the calculator that this is the case, that it is this number. So what I'm going to do is I'm going to divide 9.8 by this number, and then I want to multiply by this number squared, right, to get the mass of the Earth. So it's 9.8 divided by, and then I'll put 6.67 and do this EE button to the negative 11th. Okay? And then I'm going to multiply by this, and I'm going to put it in parentheses so that I can square it